Assalamualaikum, hello everyone. Today I want to present you a hurricane study case. Our lab is a failure analysis laboratory at the faculty FTE. Our name group is Vice Horseman. My Muhammad Ashraf SAP is one in this group. Move on. On our objective and methodology, our primary goal is to study, to identify and assess hazard from the failure analysis laboratory. From there, we aim to recommend appropriate control measure using the hazard of the control. Finally, we apply the professional engineering safety standard in practical as requirement under ENJ 41102 at UCT National Police. To achieve this objective, we follow the schedule 3-step methodology. First, we conduct a physical site visit to failure analysis laboratory. Second, we interview the lab officer Encik Azlan to gain first-hand operation insight. And third one is we perform and talk the view regulation literally specified focus on OSH at 1994 and the USECHH regulation 2000. That's all for me. Next.
Okay. My name is Muhammad. So I'll be maintaining the case area study. So here we have 4 points: core function, key equipments, the government preparation, and finally the lab environment. So with the core functions, mostly is for the microelectric inspection or defect, and also we have the wafer and die excursion, and then we have the key equipment, which are using the microelectronic and also the protection using for cleaning acids and regulars. And then we have the regulation, government regulation, OSHA Act 1994, and also the Environmental Quality Act 1974. And then lastly, the lab environment is being conducted in KTE's lab, with the main point would be using a lab that is focused on chemical, handling the chemical acids, and also the inspection of semiconductors or microchips. The first hazard that has been that we encountered was the first hazard one was the chemical hazard. So the description of the chemical hazard is being that is acid nitric that can be harm to the human when doing microcadating. That when they're doing that the handling of the chemical, they sometimes might cause burns on the skin and even eye damage. The chemical hazard scored a very high level of risk, with the severity 2 and punch weight 3, giving a 6 score of very dangerous hazard. Okay, for the incident control, it is mandatory to have acid fumes or coats to extract the dangerous fumes when handling it in the laboratory. It is very mandatory. In order to handle any chemicals we need a laboratory, you need acid fumes or hoops to exhaust fan, using an exhaust fan to suck it out. And for the PPE or the PPE requirement, it is mandatory as well to use a full laboratory suit, and also super nitric acid glove, and eye shades or spectacles or the specific type to avoid the eye damage. And also with the lab coat, we can also avoid the skin getting burned if any acid or chemicals have contact with the skin. It is very important to use the proper attire or equipment when handling any chemical within the laboratory.
Assalamualaikum, my name is Muhammad Shafiq and I'll be presenting about hazard 2, which is mechanical risk. This hazard came from high-speed rotating patterns used in a large tape prep branding and polishing machine during sample preparation. These rotating parts can cause serious injuries such as entanglement of loose clothing or lanyards or long hairs, may result in deep cuts or laceration. For the risk assessment, the hazard is classified as medium risk, which is score of form calculated from likelihood of occurrence is relatively low when procedures are followed. The consequences can still be significant if contact with the rotating pattern occurs. To control this hazard, we propose an engineering control, which is installation of transparent interlocking safety cover. The machine will automatically stop if the cover is open during operation. preventing accidental contact with moving parts. In conclusion, by combining engineering and administrative control, the risk of mechanical injury can be effectively reduced, creating a lethal laboratory environment. That's it for my part, and I will pass the next slide to my friend.
My name is Ahmad Zaikus everyday. I will explain about hazard 3 and hazard 4, which are agronomic and electrical hazard. For the agronomic hazard, workers may experience muscle strain and eye fatigue due to prolonged sitting and microscope work. The risk score is 4, which is a medium risk. To reduce the risk, ergonomic chairs, a monitor position, and regular breaks are recommended. For the electrical hazard, multi-socket extension and electrical equipment near polishing fluid may cause electric shock or fire. The risk score is also 4, which is a medium risk. Control measures include regular equipment inspection and keeping electrical source away from liquid event. In conclusion, both hazards have a middle risk level and can be controlled through proper safety measures. I will pass to the next person. Thank you.
My name is Om Prishap. I will continue the slide. So now we'll talk about environmental and societal impact. Okay, the Failure Analysis Laboratory generates hazardous chemical waste during its operations. Therefore, proper waste management is essential to protect both the environment and public health. All acid waste and chemical contaminated materials are collected in label containers and segregated according to their chemical types. These type of waste are often disposed of by licensed hazardous waste contractors in compliance with the Environmental Quality Act 1974. By following these regulations, professional engineers can minimize environmental damage and contribute to sustainable engineering practices while ensuring the safety of surrounding communities. Okay, for conclusion, in conclusion, this hierarchy study successfully identified the major chemical, mechanical, ergonomic, and electrical hazards present in the Failure Analysis Laboratory. Appropriate control measures, including engineering controls, administrative controls, and the use of PPEs, are essential to reduce risk and ensure a safe working environment. Overall, safety should always be integrated into engineering practice and remain a top priority for all engineers. That's all from me. Thank you.